So hello everyone. I am well aware that I am all that is standing between you and lunch. So I will try to make this as short and as interesting as possible. So for those of you who haven't met yet, my name is Shweta Shah. I lead product management and engineering for the Intelligent Transportation Systems line of business at Geotab. That is a mouthful. We are rebranding. I am based out of Austin. However, I don't know if Sarah's still in the room, but I have been working for Canadian companies for the last 8 or so years. So I do consider myself an honorary Canadian as well. But yeah, going to take a little bit of a local spin on the presentation here, but everything I'm talking about can be applied more broadly and globally. So I'm going to be discussing how we can support the transition of EVs to maximize their impact, and go over a few examples and pertinent data and metrics so we can really boost how those low emission or zero emission miles are being driven. Okay, so I'll take a quick step back before we jump into the data itself, and I won't spend much time here because a lot of people have already kind of discussed this. But why is this transition important? And we're driven by necessity. More countries and states have adopted policy for moving to zero-emission vehicle targets. And building on what Mark spoke about this morning, range anxiety is no longer the biggest hurdle. It's really about making sure that the EVs are in the right place and the infrastructure is in place to support and do the job appropriately. So given that EVs are absolutely up to the task, how can we support this transition? And Britta spoke about, what EPRI's doing, and Geotab has supported that initiative as well with data. So we're going to be going through some of that here. So here, taking a bit of a step out from Austin itself and looking at Texas as a whole, we could see that there's massive potential for EV adoption within the state of Texas. And for this particular study, we looked at around 85,000 vehicles equipped with Geotab telematics devices across the state of Texas for light, medium duty trucks, as well as multi-purpose vehicles. And in the last 3 months, we kind of tracked the data and looking at expected or historical driving range, as well as how long vehicles are coming back to their depot and stopping. We saw that about 90% of these vehicles are driving in a manner that operationally would allow them to electrify without really any significant impact on how they would operate and do their business today. So if 90% of these vehicles could electrify, why aren't they doing it now? And so there's a little bit of the question that I'm looking to address here today, and it's kind of what we can do to support this transition. So the first thing is, making sure that the replacement vehicles are suitable for whatever work that the current ICE vehicles are doing. So when transitioning to EV, we have a few factors to consider. OEM specifications are always available, but the truth is that vehicles rarely operate at the optimal temperature range. And so what we're able to do is work directly with fleets to understand real duty cycles for these vehicles, understanding the driving behavior of what these vehicles are going under, the terrain, the cargo, the routes they're taking, the temperature these vehicles are operating under, all can have an impact on expected range. And so we're able to help these fleets determine which vehicles are suitable to replace and also what the replacement vehicle should look like. So that's kind of one factor. And then the other is on the infrastructure side, which is where my team and what we do for the line of business. And so we talk about transitioning the vehicles themselves. We also want to know about the infrastructure that's needed to support them. So this infrastructure can be in place at the depots themselves or, in en route charging. And so depot charging infrastructure presents its own set of challenges. There's shared infrastructure at ports and at large distribution centers. So it's not always up to like a singular fleet to plan for. And so what we can do is looking at data kind of in aggregate and across many fleets, kind of give, what Britta spoke about, like a little bit of a heads up to the utilities on, hey, these are areas that are likely to electrify based on existing movement patterns of ICE vehicles today. So we can consider not only just the number of vehicles, but the vehicle class, the types of vehicles that are moving, which all will inform, how much load is expected on the grid and the capacity needed. So for this kind of example in Houston, we saw approximately 11,000 vehicles are ready to electrify today. Over half of them are operating in a hub and spoke manner, which means they leave their depot, go out, do a job, do a delivery, do something, and then come back to the depot. So those types of movements are prime for electrification, right? They're going to come back to a known spot for some period of time where they could charge. So as we consider where to focus our efforts to make zero emission vehicle miles a reality, these figures give us a good place to start. Okay. And in addition to the depot charging, we also want to look at en route charging. And because reality is depot charging isn't always an option. For the Mack trucks, they're likely not coming back and circling back to a depot before they run out of range. And so for this particular study, we looked at heavy-duty vehicles in the Austin area, Austin and then the surrounding suburbs to the north, again, the past 3 months. And we found a number of kind of hotspots lit up on the map of where these vehicles are already stopping today. We probably may not be able to see it, but focused in on a very singular hexagon at the bottom of the map there, where there was over 31,000 heavy-duty stops from heavy-duty vehicles there. And so what we can do is, taking a look at this data, we can see that most of those vehicles are stopping in the evening time. They're staying there anywhere from 2 to 4 hours. There's a lot of activity there. This could be a potential spot to put in the infrastructure needed to support heavy-duty vehicles, and give the utilities a heads up on, hey, these areas are likely going to be coming online and into play. Okay. All right, I think I made it well under my allotted time to get you guys out to lunch. So really, just in conclusion, we're past the point of asking if EVs can do the job, right? It's more about how can we make this transition as painless as possible? How can we get ahead of it in terms of the infrastructure that's needed to support it? So EV performance characteristics, vehicle movement insights, contextual data, they're all going to play a role in making these smart decisions. And with reliable mobility insights from vehicle movement data, we're able to do that. So all the stats and graphs that I provided you today are available through the Altitude platform from Geotab. And if any of you are working in EV infrastructure and are kind of asking similar questions to this, I would absolutely be interested in chatting with you. And yeah, let's connect.